Hello students, welcome to your how-to video to use the periodic table on the isotopes option. If you go to the interactive periodic table that's in the left-hand menu, you will actually be brought to the properties tab. So if you go that route, you need to make sure that you are in the isotopes tab, and that should be highlighted in blue like you see on my screen. I'm going to show you how to use this option when it comes to doing your week 4 inquiry. And I'm going to go through the steps that I used to do my example. Now, I started with the parent isotope ytterbium-161. You need to know both the element symbol and the mass number for this to work. I will find ytterbium, which is YB, and if you click on that, it opens isotopes. And you can scroll up and down, and my job is to find ytterbium-61, which I found here. And you'll notice that ytterbium-61 is outlined in purple. If you want it where it stays on the isotope you have, you can click on it. It'll bring up a Wikipedia site, and you can exit out of this. And it'll leave it on ytterbium-161 for me. Now, if I scroll up, it tells me I have a positron emission in terms of this going through radioactive decay. So I know I can expect to write a positron emission decay equation for ytterbium-61. I also want to write down the half-life, and you'll notice over here there's a bunch of information, and then there's also this half-life row, and it tells you the half-life is 4.17 minutes. So make sure that you write down what type of decay it goes through and the half-life. You can write the equations as you go, or you can write down simply what kind of radioactive decay it will go through and the half-life. It's entirely up to you on how you want to approach this. However, you need to know what your daughter isotope will be in order to check your next isotope. So if I have ytterbium go through positron emission or positron decay, it's going to lose a proton and move down to thulium, which is the atomic number 69. The mass number does not change with positron emission, so I have to find thulium-61, which is right here. And again, I click on it to lock it in place, and thulium-61 is also going to go through positron emission, and then the half-life is 30.17 minutes. Again, positron emission loses a proton. Mass number will stay the same. So I find erbium, which is 1 less proton, which is 68 for atomic number, and the mass is still 161. It's still outlined in purple, which means it's still a positron emission or positron decay. And then if you notice in your half-life, it's 3.22 hours. So this is a different unit, and this is why I tell everybody to be mindful of your units of half-life. The next one is holmium, and I click on holmium because it goes through positron emission, same thing. And now I get to holmium-161 here, and it's a dashed purple line. And this one is electron capture. So it's a different form of radioactive decay than what I've been doing. So I have to make sure that I write that differently. The half-life for this is also 2.48 hours. So again, units, be mindful. With electron capture, holmium will capture an electron. It'll be reduced by 1 proton, which gives it an atomic number of 66. It'll also lose an X-ray byproduct. And then my mass number will stay the same with electron capture as well. So now if I go down to dysprosium, I will find dysprosium-161. And if I click on that, I'll notice that it's outlined in a black outline, and then up here it tells me that it is stable. So that is my stable daughter isotope, or the goal that I'm going for this activity. Please note that when you reach your stable product, stable products do not have a half-life because they're not going to go through radioactive decay. So we don't have to worry about that with our stable daughter isotope. This was your how-to video to use the periodic table in the isotope function in order to complete your week 4 inquiry. As always, if you need help, make sure to reach out and ask me. Be sure to pay attention to your key up here, as well as the border that is around your isotopes. And be mindful of your mass number, because that's going to be the trick when it comes to finding the isotope and specifically what type of radioactive decay that isotope will go through.